In this video, we'll be working through some practice problems on integration. We'll cover a range of techniques, from basic power rule integration to more advanced methods like substitution and integration by parts. Let's get started with the first set of problems. Let's start with question 17a. We need to find the integral of 2x times the quantity x squared plus 4, all raised to the power of 3, with respect to x. This looks like a good candidate for u substitution. Let's set u equal to the expression inside the parentheses. Now we find the derivative of u with respect to x. Rearranging this, we get du equals 2x dx. Now we can substitute u and du into our integral. This is a simple power rule integration. We add 1 to the exponent and divide by the new exponent. Finally, we substitute back x squared plus 4 for u. So the integral of 2x times the quantity x squared plus 4 cubed dx is x squared plus 4 to the power of 4 all over 4 plus c. Let's move on to question 17b. We need to find the integral of 4x cubed times the quantity x to the 4th minus 2 raised to the power of 3/2 with respect to x. Again, this looks like a good candidate for u substitution. Let's set u equal to the expression inside the parentheses. Now, we find the derivative of u with respect to x. Rearranging this, we get du equals 4x cubed dx. Now we can substitute u and du into our integral. Using the power rule for integration, we add 1 to the exponent and divide by the new exponent. Finally, we substitute back x to the 4th minus 2 for u. Now for question 18a. We need to find the integral of cosine x times sine cubed x dx. This is another substitution problem. Let's set u equal to sine x. The derivative of u with respect to x is cos of x. Now we can substitute u and du into our integral. Using the power rule for integration, we get. Finally, we substitute back sine x for u. So the integral of cosine x times sine cubed x dx is sine to the 4th of x over 4 plus c. Let's tackle question 18b. We need to find the integral of negative sine x times cosine squared x dx. This is another substitution problem. Let's set u equal to cos of x. The derivative of u with respect to x is negative sine x. Now we can substitute u and du into our integral. Using the power rule for integration, we get. Finally, we substitute back cos of x for u. So the integral of negative sine x times cosine squared x dx is cosine cubed of x over 3 plus c. Now for question 19a. We need to find the integral of 3x squared plus 2 dabad x cubed plus 2x dx. This integral is in the form of f dash of x divided by f of x. Let's check. Let f of x equals x cubed plus 2x. Then the derivative, f dash of x, is 3x squared plus 2. So the integral is of the form integral f dot Planck's slash fx dx, which integrates to ln fx plus c. Therefore, the integral is the natural logarithm of the absolute value of x cubed plus 2x plus a constant c. Let's look at question 19b. We need to find the integral of 4x cubed dash 5 divided by x to the power of 4/5 x dx. This is another integral in the form of f dash of x divided by fx. Let's verify. Let f of x equals x to the power of 4/5x. The derivative, f dash of x, is 4x cubed dash 5. So the integral is indeed of the form integral f dash of x slash fx dx, which integrates to ln fx plus c. Therefore, the integral is the natural logarithm of the absolute value of x to the 4th minus 5x plus a constant c. Moving on to question 20a. We need to find the integral of x squared times the square root of x cubed plus 4 dx. This looks like a case for u substitution. Let's set u equal to the expression inside the square root. Then, the differential du is 3x squared dx. We can substitute u and 1/3 du into the integral. Now we integrate with respect to u. Finally, substitute back x cubed plus 4 for u. So the result is 2/9 times the quantity x cubed plus 4 to the power of 3/2 plus c. Next, question 20b. We need to find the integral of x times the cube root of 1 minus x squared dx. Let's use u substitution again. Let u be the expression inside the cube root. Then, the differential du is minus 2x dx. Now we substitute u and minus 1/2 du into the integral. Integrating with respect to u gives us, finally, substitute back 1 minus x squared for u. So the result is negative 3/8 times the quantity 1 minus x squared to the power of 4/3 plus c. Let's look at question 21a. We need to find the integral of 4x times e to the power of negative x squared dx. This is another problem for u substitution. Let's set u equal to the exponent of e. Then, the differential du is minus 2x dx. Now we can substitute u and minus 2 du into the integral. The integral of e to the u is just e to the u. Finally, substitute back negative x squared for u. So the result is negative 2 times e to the power of negative x squared plus c. Now for question 21b. We need to find the integral of 9x squared times e to the power of x cubed dx. Again, we'll use u substitution. Let u be the exponent of e. Then, the differential du is 3x squared dx. Now we can substitute u and 3 du into the integral. The integral of e to the u is e to the u. Finally, substitute back x cubed for u. So the result is 3 times e to the power of x cubed plus c. Let's tackle question 22a. We need to find the integral of x squared divided by the quantity x cubed plus 5 dx. This looks like a case for u substitution, where the numerator is related to the derivative of the denominator. Then, the differential du is 3x squared dx. Now we can substitute u and 1/3 du into the integral. The integral of 1 over u is the natural logarithm of the absolute value of u. Finally, substitute back x cubed plus 5 for u. So the result is 1/3 times the natural logarithm of the absolute value of x cubed plus 5 plus c. Now for question 22b. We need to find the integral of x cubed divided by the quantity x to the 4th minus 3 dx. Similar to the previous problem, we'll use u substitution. Let u be the denominator. Then, the differential du is 4x cubed dx. Now we substitute u and 1/4 du into the integral. The integral of 1 over u is the natural logarithm of the absolute value of u. Finally, substitute back x to the 4th minus 3 for u. So the result is 1/4 times the natural logarithm of the absolute value of x to the 4th minus 3 plus c. Let's move on to question 23. We are given that dy dx equals 3 times the square root of x and y equals 12 when x equals 9. We need to find an expression for y in terms of x. First, we need to integrate dy slide dx to find y, using the power rule for integration. Now we use the given condition, y9 equals 12, to find the constant c. Since 9 to the power of 3/2 is the square root of 9 cubed, which is 3 cubed or 27. So the value of c is minus 42. Therefore, the expression for y in terms of x is 2 times x to the power of 3/2 minus 42. Question 24 gives us a function f, such that f prime of x equals 2 cosine x minus 3 sine x, and f of 0 equals 5. We need to find the expression for f of x. First, we integrate f dash of x to find f of x. We can integrate term by term. The integral of cos of x is sine of x, and the integral of sine of x is negative cos of x. Now we use the condition f of 0 equals 5 to find c. Since sine 0 is 0 and cos 0 is 1, we have. So the constant c is 2. Therefore, the expression for f of x is 2 sine x plus 3 cosine x plus 2. Let's solve question 25. We are given dy by dx equals 2 e caret x, negative 5 slash x, and y equals 0 when x equals 1. We need to find an expression for y in terms of x. First, we integrate dy squared dx to find y. We can integrate term by term. The integral of e caret x is e caret x, and the integral of 1 slash x is ln x. Now we use the condition y1 equals 0 to find c. Since ln1 is 0, we have. So the constant c is minus 2e. Therefore, the expression for y in terms of x is 2 e to the x minus 5 times the natural log of the absolute value of x minus 2e. Let's tackle question 26. We need to find the integral of 4x squared plus 3 divided by 2x dx. First, we can split the fraction into two parts. Now we can integrate each term separately. The integral of 2x is x squared, and the integral of 1 slash x is ln x. So the result is x squared plus 3/2 times the natural log of the absolute value of x plus c. Next, question 27. We are given dv slash dt equals t minus 1/2 sine t, and v equals 2 when t equals 0. We need to find an expression for v in terms of t. First, we integrate dv slash dt to find v. We integrate term by term. The integral of t is t squared over 2, and the integral of sine t is negative cosine of t. Now we use the condition v, 0, equals 2 to find c. Since cosine of 0 is 1, we have. So the constant c is 3/2. Therefore, the expression for v in terms of t is t squared over 2 plus 1/2 cosine of t plus 3 over 2. Let's solve question 28. It is given that x0 equals 5 and dx for dt equals 5 to 2e caret t. We need to find an expression for x in terms of t. First, we integrate dx dt to find x of t. We integrate term by term. The integral of 5 is 5t, and the integral of 2e caret t is 2e caret t. Now we use the condition x of 0 equals 5 to find c. Since e caret 0 is 1, we have. So the constant c is 7. Therefore, the expression for x in terms of t is 5t minus 2 e to the t plus 7. Let's move on to question 29. We need to find the integral of 5 to 2x to the power of 6 dx. This is a case for using the reverse chain rule, or a simple u substitution. Let u equals 5 to 2x. Let u equals 5 to 2x. Then du equals minus 2 dx, which means dx equals minus 1/2 du. Now we integrate with respect to u. Finally, substitute back 5 to 2x for u. So the result is negative 5 minus 2x to the power of 7 all divided by 14 plus c. Next, question 30. We need to find the integral of 3 sine 2x dash 2 cos 3x dx. We can integrate this term by term. For the first term, the integral of sine 2x is minus 1/2 cos 2x. For the second term, the integral of cos 3x is 1/3 sine 3x. Simplifying this gives us our final answer. So the result is negative 3/2 cos 2x minus 2/3 sine 3x plus c. Let's look at question 31. We need to find the integral of 2x times x squared plus 1 to the power of 5 dx. This is another problem that can be solved using u substitution. Let u equals x squared plus 1. Then du equals 2x dx. Now we integrate with respect to u. Finally, substitute back x squared plus 1 for u. So the result is x squared plus 1 to the power of 6, all divided by 6 plus c. Question 32 gives us dy dx equals x sine 3x squared and asks for an expression for y in terms of x. we need to integrate x sine 3x squared dx. Let's use u substitution. Let u equals 3x squared. Then du equals 6x dx, which means x dx equals du/6. The integral of sine u is Kevchi. Substituting back, u equals 3x squared gives us the final answer. So y is equal to negative 1/6 of cosine of 3x squared plus a constant c. Let's solve question 33. We need to find the integral of 3x over the square root of x squared plus 2 dx. We can use u substitution here. Let u equals x squared plus 2. Then du equals 2x dx, which means x dx equals du/2. Now we integrate with respect to u. Finally, substitute back u equals x squared plus 2. So the result is 3 times the square root of x squared plus 2, plus c. For question 34, we are given f dash of x equals 1 slash 2x plus 3 squared, and that the graph of y equals f of x passes through the point, minus 1, 1. We need to find the expression for f of x. First, we integrate f dash of x to find f of x. Using the power rule for integration with a linear term inside, we get, now we use the condition f minus 1 equals 1 to find c. Solving for c, we get c equals 1 plus 1/2 equals 3/2. So the expression for f of x is minus 1 over 2 times 2x plus 3 plus 3/2. Question 35 states that the curve y equals f of x passes through the point 1, 1 and has a gradient f dash of x equals 2 ln x divided by 3x. We need to find the expression for f of x. To find f of x, we need to integrate f dash of x. This is a classic integration by substitution. Let u equals ln of x. Substituting these into the integral gives. Now substitute back u equals ln of x. We use the condition f1 equals 1 to find c. Since ln1 equals 0, we have. So the expression for f of x is 1/3 times the square of the natural log of x, plus 1. And that's our final answer for this problem. Let's look at question 36. We are given f dash of x equals 2/x and f minus 1 equals 5. We need to find the exact value of f minus 3. First, we find the antiderivative of f dash of x. Now we use the given condition f minus 1 equals 5 to find the constant c. Since ln1 equals 0, we have c equals 5. Now we can find f minus 3. So the exact value of f minus 3 is 2 times the natural logarithm of 3 plus 5. Question 37 asks us to find the integral of 4 cos cubed x sine x plus kx squared plus 1 dx, where k is a constant. We can integrate this term by term. For the first term, let's use substitution. Let u equals cos of x, so du equals dash sine of x dx. The integral of the first term is nash cos to the power of 4x. The integral of the second term is k times x cubed over 3. And the integral of 1 is x. Combining these results, the final answer is negative cos to the power of 4x plus k slash 3, x cubed plus x plus c, where c is the constant of integration. Let's tackle question 38. We need to find the integral of e caret 2x minus e caret minus 2x divided e caret x dx. First, let's simplify the integrand by dividing each term in the numerator by the denominator. Now we can integrate term by term. The integral of e caret x is e caret x. For the second term, we use the rule integral e caret ax dx equals 1 slash a e caret ax. So the result is e to the x plus 1/3 e to the minus 3x plus c. Question 39 asks us to find the integral of the square root of x to the power of 4 plus x squared dx for x greater than 0. First, let's simplify the expression inside the square root by factoring out x squared. Since x greater than 0 equals x, so the integral becomes. Now we can use u substitution. Let u equals x squared plus 1. Substituting these into the integral, integrating with respect to u. Finally, substitute back u equals x squared plus 1. So the result is 1/3 times the quantity x squared plus 1 to the power of 3/2 plus c. Let's move to question 40. Part A asks us to show that sine squared x is equal to 1/2 times 1 minus cosine of 2x, starting from a double angle identity for cosine. We start with the double angle identity for cosine. Cos 2x equals cos squared x, sine squared x. We also know the Pythagorean identity. Sine squared x plus cos squared x equals 1, which means cos squared x equals 1 dash sine squared x. Now, we rearrange this equation to solve for sine squared x. Finally, divide by 2, and that's the identity we wanted to show. Now for part B, we need to find the integral of sine squared x dx. Using the identity we just proved, we can rewrite the integral. We can take the constant 1/2 out and integrate term by term. The integral of 1 is x, and the integral of cos 2x is 1/2 sine 2x. So the integral of sine squared x is 1/2 x minus 1/4 sine of 2x plus c. Question 41 is similar. First, in part A, we need to express cos 2x in terms of sine x. We use the double angle identity for cosine. Cos 2x equals cos squared x sine squared x. We also use the Pythagorean identity sine squared x plus cos squared x equals 1, which gives us cos squared x equals 1 dashes sine squared x. So cos 2x is equal to 1 minus 2 times sine squared x. Now for part B, we need to find the integral of sine squared x dx again. From part A, we have cos 2x equals 1 to 2 sine squared x. We can rearrange this to solve for sine squared x. Now we integrate this expression. Integrating term by term, we get. This is the same result as in question 40b as expected. Let's move on to question 42. We need to find the integral of tan x dx, showing all our working. First, we rewrite tan of x as sine of x over cos of x. This is in the form of negative ff dash of x, where f f x equals cos of x, and f dash of x equals sine of x. So we can rewrite it as the integral of negative fx slash fx is negative ln fx. Using logarithm properties, this can also be written as ln sec x plus c. Next, question 43 asks for the integral of sine cubed x dx. We can rewrite sine cubed x as sine x times sine squared x. Using the Pythagorean identity, sine squared x equals 1 minus cos squared x. Now we can integrate term by term. The integral of sine x is negative cos x. For the second integral, we use substitution with u equals cos x, so du equals negative sine x dx. Integrating u squared gives u cubed over 3. So the final answer is negative cos x plus 1/3 cos cubed x plus c. Finally, let's tackle question 44. We need to find the integral of 1 over x times ln of x dx. This can be rewritten as the integral of 1 slash x divided by ln of x. This is another integral in the form of f dash of x divided by fx. Let f of x equals ln of x. Then the derivative, f dash of x, is 1 slash x. So the integral is of the form integral f dash x slash fx dx, which integrates to ln fx plus c. Therefore, the integral is the natural logarithm of the absolute value of the natural logarithm of x plus a constant c.